this video, we're going to start tackling some 8th grade lessons. We're going to specifically focus on lessons 14 through 29, where we will dive deep into some algebraic concepts involving linear equations. In lesson 14, we're going to talk about horizontal and vertical lines. But before we do that, we have to tackle some vocabulary. We will be using these vocabulary terms specifically very often, and we need to make sure that you know what they mean. The x-axis and the y-axis, they're both essentially two number lines. The x-axis is a number line that goes from left to right, and the y-axis is a number line that goes up and down. And when we put them together, they form a coordinate plane like we see here in the image. So if you feel comfortable with what the x-axis and y-axis are, let's go ahead and try to fill in these sentences. Think of an ordered pair that would fit into these particular slots. What would be an example of a point that lies on the x-axis, the y-axis, and one that lies on neither the x or y-axis? Well, if I'm looking for a point that lies on the x-axis, which would be this axis right here, that number line, then I could virtually put a point anywhere in there. And so I'm going to pick this particular one. And when I look at what the coordinates for that point would be, I know that my x-coordinate goes before my y-coordinate, and they're separated by a comma. So I know that if this is a point that lies where x equals 2, my y value is going to be 0 because y equals 0 is right here. So 2, 0 would be an example of a point that lies on the x-axis. Similarly, if we're looking for a point that lies on the y-axis, which is the number line that goes up and down, I could put a point anywhere in there and pull out the ordered pairs. Again, my x value is always going to go first and my y value next, separated by a comma. So when I look at this particular value, I see that y is 3 and x is 0. So 0, 3 would be an example of a point that lies on the y-axis exclusively. And the last sentence, give us an example of a point that does not lie on either. You can basically put a point anywhere in this coordinate plane that does not lie on an axis or the number line. So we could have this point right here, or we could also have a point up here, or we could put a point right here. That would be x value -2, y value 2. We could actually put any point that does not lie on the axis and it would fit this sentence. So I'm going to use 3, -3. One of the things that is important for you to notice is that when you have a point that lies on an axis, the axis that it does not lie on is going to give you a value of 0. Let's look at the word parallel. The word parallel simply refers to when two line or line segments have the same slope. And so you might have them very close together like that, or you may have them very far apart like that. They might also go in opposite and have a negative slope. But the main point is that they never intersect. They never cross at any point. Because if they're moving in that direction and they're moving in the same slope, there will never be a time where they cross. So an image that we usually use to explain this concept is train tracks. Train tracks have to have the same distance from each other, but more importantly, they have to have the same slope. So train tracks are never going to intersect with each other. The only time this would happen is if, of course, we have other set of train tracks, right? But what would be another example of a parallel lines? The term horizontal refers to lines or line segments that have no slope, meaning they move from left to right without any kind of inclination. An x-axis would be an example of a horizontal line because it moves from left to right in the coordinate plane. What would be another example of a horizontal line? The horizon is usually referred to as horizontal. The sidewalk that you walk in can also be referred to as a horizontal line if that sidewalk has no slope. When two lines are perpendicular, they are intersecting at a 90-degree angle. So we might have one line and it can intersect, and we can have a different line that intersects that line at any point. And as long as it intersects or it crosses it at a 90-degree angle, then that means they are perpendicular. So if I have line A here and we have line B in purple, then I can say that line A is perpendicular to line B. This is a picture of the San Francisco Golden Gate Bridge. If you notice, we have the actual street that cars are driving on, and then we have this structure that's holding the bridge together. It is safe to say that this is an example of a perpendicular situation where the structure and the street intersect each other at a 90-degree angle. When something is vertical, it's basically going up and down. And when things go up and down, especially lines, we say that they have an undefined slope. An example of this would be vertical blinds. We have different kinds of blinds, but the vertical blinds go up and down, and they tend to be usually long and right in front of some sort of glass sliding door. The y-axis is an example of a vertical line because it goes up and down with no slope. In lesson 14, we are looking at the graph of linear equations that form horizontal and vertical lines. So let's look at this first example. I'm going to plug in 0 for A, and I'm going to plug in 1 for B, and I'm going to plug in 2.5 for C. If I were to do that, I know that because of the zero property of multiplication, anything multiplied times a 0 is going to be 0. And so when you have the variable multiplied by a 0, you're automatically going to get a 0 product. So this linear equation all of a sudden becomes a one variable equation. Our equation is now y equals 2.5. And when that happens, that basically gives us an infinite number of points because the point is going to lie on the y-axis. Let me show you what this would look like. If y is 2.5 and x is 0, because I substituted the 0 for the x, remember that? Then I'm only going to be graphing in the y-axis. I'm going to find 2.5, which is going to be right over here, and I'm going to graph my point. Now this problem tells us that this is a linear equation. So this is going to form a line. This is the equation of the line, and these are some of the values for that line. So I know that if this point is going to belong to a line, and this line has no slope because the constant that's next to x is 0, then this line is going to be a horizontal line. The horizontal line is going to be parallel to my x-axis. So we can say that in this case, y equals 2.5 is parallel to the x-axis. We're going to use this symbol to say that they are parallel. Let's look at our next example. We have a linear equation which tells us that we're going to be forming a line, and we have a equals 1, b equals 0, and c equals -6/4. So I'm going to go ahead and start substituting. For a, 1, for b, 0. Now we know, just like we did from the example before, that because of the multiplication property, anything times a 0 is going to give me a 0. So all of a sudden, this equation becomes a one variable equation where x equals -6/4. So I'm going to graph exclusively in the x-axis. My ordered pair will be -6/4, and y is going to be a 0. Now 6/4 can be reduced. So if I go ahead and reduce this by dividing each side by 2, for example, I would get a -3/2, which is basically a -1.5, and that point would lie right over here. And if I were to draw a line that passes through that point, it doesn't not need to be a dotted line. It can also be a straight up line. What I notice is that this is going to be a vertical line. This vertical line is going to be parallel to the y-axis. They both are going to have an undefined slope. And if you notice, when one of the lines is parallel to an axis, then it automatically means it's perpendicular to the other axis. So if I'm looking at this particular line, x equals -6/4, yes, it is parallel to my y-axis, but it's also perpendicular to my x-axis, right? So x equals -6/4 is perpendicular to the x-axis. And we're going to use this symbol to say it's perpendicular. Sometimes you will see this symbol being used as well.